Hello, today we're going to look at circle theorems, and we're also going to look at an example of applying circle theorems. So we'll run through these circle theorems first of all, the three circle theorems here, and then we'll do an example. So I'll start off with this circle theorem first. So if you've got a triangle within a circle, and one of the sides of that triangle is a diameter, so if you draw the diameter first of all, and then you draw from the ends of the diameter to anywhere on the outside of the circle, the circumference of the circle, then that triangle will form a right angle. So as long as the base is diameter and from the ends of the diameter joins up to anywhere on the outside of the circle, then there'll be a right angle in here. And we often refer to that as angles in a semicircle are right angled. This one here, we've drawn a radius. To the outside of the circle, or the perimeter of the circle. And also what we've drawn is a tangent. If you don't know what a tangent is, it's a straight line that cuts, in this case, a circle, or touches the circle at one point. So a radius is at right angles to the tangent, where the radius touches that circle. And the final circle theorem, again, we've got a radius. And if we draw a chord, now if the chord is bisected, and with these two little lines either side, that means we bisect it, then it's at right angles. Or you could say, if the chord is at right angles to the radius, then it bisects, then the radius bisects the chord. Right, let's move on to an example. Now this is a very common example they like asking in exams. So we've got an oil tanker and there's a circular cross section of diameter 4 meters. Surface of the oil is 2.8 meters from the top of the tank. What is the width of the surface of the oil? Well, I think a diagram will certainly help us here. I think we'll start that again. I'll try and do another circle. That's a bit better. Okay, center of the circle, and we've got diameter 4, and the surface of the oil is 2.8 meters from the top of the tank. So it's somewhere roughly about there. So the oil must be here. So that's 2 meters, because my diameter is 4, if the radius is 2 meters. So here, that must be 0.8 meters. Now what do we ask for? We're asked for the width of the surface of the oil. So we're asked for this length here. Right, I think what we'll do is we'll put in some more measurements. And I think we can use a triangle here. Let's have a look. So if we joined up the center to the outside, that's a radius, so that'd be 2. And if I made a little triangle here, you can hopefully see that'd be right angled. So I'm just going to draw this as a little sketch down here. Let's make it a little bit neater. So that's 0.8, that's 2. No, that's slightly wrong. The 2's there. So if we can find this length, then by our circle theorem, because our radius is going to be at right angles to the chord, therefore that length will be the same as that. So if we can find that length, then we can double it to find the whole of the surface of the oil. So we've got, we're going to use Pythagoras' hypotenuse squared. Hypotenuse in this case, 2, opposite the right angle, so 2 squared equals 0.8 squared, and let's call that x, what we're looking for, plus x squared. 2 squared 4, 0.8 squared, 0.64 plus x squared. Subtract 0.64 from either side, and we get x squared equals 3.36. So x is going to equal the square root of 3.36. So what we've found is we've found that length from there to there. That's x. And also here is x. Now, to find the total surface of the hole, we just got to double that. So the surface would be 2 multiplied by the square root of 3.36. And I don't have my calculator handy, but I'm sure you could use your calculator. But that's as exact as it can be. Goodbye, and thanks for watching.